The topic of the presentation is on how to monitor the external training load. We will proceed by steps, so we start looking at what is training load and how to monitor it, and then we will see how the speed skating data is working on this topic and what is the perspective for the future of training programming and monitoring. Let's have a look at what training load is. As a definition, training load is the term used to define, measure, and compare all the training variables that can be considered a stimulus imposed to the athlete. We can have an external training load and an internal training load, and we'll cover it in a while. So basically, when we talk training load, we are just talking about what we are doing during a training session with our athlete. So the external training load is an objective measure of, again, what we are doing during a training session. In inline speed skating is pretty straightforward. It's pretty easy. If you are a coach or if you are even an athlete, you already know at least 3 external variables. If the external training load is what we do, the internal training load is what we are doing on our body. So basically every physiological response to the stressors we are imposing to the body through our training. Again, it's pretty easy to find a couple of internal load. You can find here on the side. Internal load can be heart rate, maybe RPE, so measurements or fatigue or perceived fatigue, or maybe lactate production during a training. Okay, so basically everything to measure what is the response of our body to the training intervention. Here is the answer to the question. The internal parameters can be perception of effort, rate parameters, blood lactate concentrations, blood lactate to RPE ratio, everything similar. And then the external load is pretty straightforward in speed skating, which is like for how long you skate, what distance do you cover when you're skating, how you monitor it. So maybe with the GPS, or we cover it later out how we do in speed skating data. Or maybe if we are training in the weight room, it's just how much weight there is on the barbell and you are lifting. The external training load in inline speed skating is pretty much as you can see here. So we got distance, which is useful, let's say, when we train. So it's useful to know, well, today I'm doing 20 kilometers, tomorrow 30, next day I'm doing 2 kilometers, maybe high intensity. And it's very easy to calculate the distance cover. If you are on a track, you just count the number of laps. If you are on the street, you maybe can have a look at your GPS or something like that. And the same can be said for the time. So it's pretty easy to say, today I'm skating 1 hour. It's pretty easy to measure it with just a stopwatch or clock. Then we have some better maybe parameters. So speed allows us to combine distance and time. It's pretty good to know at what speed you are moving, because as you remember, we do speed skating. So speed is the king of the parameters for a speed skater. It's pretty, let's say, easy to calculate speed. If you're training on a track, you just record the times you are doing, and then when you came home, you can do some easy calculation and see at what speed were you moving. It's highly difficult to measure instant speed. If you want to know what our speed is when we enter a corner compared to the middle sector of a corner or the exit sector of a corner, it's pretty hard to do. Then we got acceleration, which is a great parameters if you want to look at neuromuscular strain. So it's pretty useful to know if you are able to accelerate, how fast you are accelerating, if you struggle with accelerating, stuff like that. And again, it's pretty hard to measure because you need an accelerometer, basically. You can do maybe some calculation with the average speed and average acceleration, but if you want to do a good work, you need an accelerometer or something more sophisticated. And then we got the power output, which is extremely difficult to measure in speed skating. Almost for now, it's impossible, because speed skating It's a pretty various sport. You run in circles, but it's pretty hard to say what is your power output. If you are interested in cycling, you already know that power meters are very widely diffused. Everything is about power in cycling, and could be the same in speed skating, but measure it's extremely difficult. There isn't a device for now that is able to do this computation for us. In the future, if we find a way to do it in a non-invasive way, it will be a game changer, of course. We have this knowledge gap. We train for speed because we are speed skater, but it's not that easy to measure speed. And if you can't measure something precisely, it's difficult to work on it and develop it. If we look at speed, it's hard to see how fast you're moving. And maybe for past years in speed skating, just knowing how fast were you moving was enough. But today, maybe we need more parameters to describe our sport better. So how we can measure speed in speed skating? We got basically three options. The first one is using a stopwatch, which is the easiest one, I believe. Is the best method for performance tests because the stopwatch give us information about our performance. Because at the end of the day, speed skating is about clock the fastest time on your lap. So it's a good starting point. You can calculate AVG speed, so average speed from some calculations, but it got some problems. The first one is that you need time to calculate the speed. The second one is that you need the stopwatch for every athlete you are monitoring. If you are a coach and you got 10 athletes, you can just focus on one athlete at a time. The last one is trajectory problem, and we will cover it later. Then we can use timing gates or transponders to measure our speed. This type of setup is very good. Is best for example, for short races because it gives us very accurate results. Can be used for AVG speed. Can measure, of course, insta speed. There are some timing gates that comes with software that allows us to have automatic calculation of speed. It allows us also to monitor some athletes simultaneously if we can have, for example, transponders. But this type of setup, of course, is very expensive and it's not portable. So maybe if you are training in two different tracks, it will be difficult to move your setup from one facility to another, and also it requires time to set all the timing gates. It's affected by the trajectory problem, and again we will cover it later. The last option is to use commercial smartwatches and use the GPS they have integrated. It's very good because you can measure multiple athletes because every athlete can have their own smartwatch. It can account for the trajectory differences. So maybe if you are skating on a track and you are skating on the inner line, you're covering less distance than the same skater on the outer line of the corner, and the GPS monitor can ideally taking into account this, but we'll see later it's not that precise, which is the main drawback of this technology. So basically, commercial smartwatches GPS don't work for speed skating, and we'll see in the next slide. The trajectory problem is this one. If you are skating on a 200-meter track, the 200-meter is of course the inner length of the track. But if you're skating on the same track, the outer leg, it can become a 220, 230 lap. So if you clock a 50-second lap, so it's a pretty fast lap in a 200-meter track, you can skate that same lap at 48 kilometers per hour if you are running the inner length or inner trajectory. But if you go on the outer trajectory, you need to go at 57 kilometers per hour to cover the same lap at the same time. It's a huge difference. 9 kilometers per hour is a very huge difference. And to take it into account, we need to address this trajectory problem. Of course, the trajectory, you can calculate it for one time, but it's constantly changing. Maybe I'm cutting from the outer trajectory to the inner trajectory during the corner, stuff like that. And the second drawback of the technologies we have already seen is poor accuracy. Here on the right side, you can see data from one of my athletes during the national championships of last year, junior category. As you can see, this is the GPS he was wearing on his wrist. And as you can see, I don't think during the race he skated outside the track or he cut the track limits and stuff like that. So if you can see, it's very not precise. We got the results, but they are not very interesting. They're not precise. Accuracy is very low. And then we got this example. These are data from 2 training session with downwind with my athletes. And as you can see on the bottom, we got the heart rate path. On the red line is the heart rate monitor. The blue line is the speed calculated with a GPS, but we will see later. And the training session is a 15 kilometer session with an acceleration at the end of every corner. So the skater were required to accelerate, stop, accelerate, stop, accelerate, stop at every corner. If you look at AVG speed, is around 37 kilometers per hour, but we got a max speed of 41 kilometers per hour and the lowest speed at 32 kilometers per hour. And if we look at the middle segment, the fastest one, okay, you will see an average heart rate of around 179, 180 BPM. The second session for this example is another long session. We will focus on the last part of it. The average speed for the last section was 37 kilometers per hour, pretty similar to the previous one. But this time the variation in speed is very low, so from 39 to 36 in a track which requires some acceleration. So it was pretty a steady state. And you can see the heart rate be pretty constant around 180 BPM. So as you can see, the two sessions are very similar in AVG speed, very similar heart rate, but different at speed. So if we just have AVG speed or lap times, the heart rate monitor, we could say that the sessions are similar, but they are not. Because if we zoom a little bit, we see a straight line for the heart rate again, and this variation in speed. Okay, so it's around 5 kilometers of acceleration. Okay, from the corner exit, from the corner middle section to the exit, and then there is a decrease in speed again. And the other section is, as you can see, there is a little variation again in speed, but is not something we are interested in. So basically, 3 lessons we learn from this example is that heart rate can be the only parameter we use to monitor the training load. Average speed is a good parameter, but a huge limitation when it comes to train on tracks and road circuits. Modern speed skating needs maybe new parameters or more precise parameters to describe our sport. Our answer is this product from K-Sport. This is an Italian company which is leader in the GPS sector for football or soccer. We tried their devices. They combine the GPS with the inertial measurement unit, which is basically an accelerometer, gyroscope, and a magnetometer. So it basically allows you to have data every 0.1 seconds. It samples at a frequency of 50 hertz, so 50 times per second, which is very good. I believe this is the best device you can have from an accuracy standpoint when it comes to GPS and accelerometers. It provides you with speed data and acceleration data too. It allows you to have instant speed. If we look at previous method we have covered, this is the only one that gives you instant speed. It allows you to do some performance analysis tests on post on their software, provide you with speed and acceleration calculation already, so it does everything on its own. You can personalize thresholds, set this threshold and work on them during your sessions. Allows to monitor multiple athletes because this is a personal device, so every athlete got it. It comes with a live streaming option available, so you can even monitor your athlete while you are skating, so you don't have to do the analysis post, but you can see maybe they are skating too slow or something like that. or if you want to increase maybe the acceleration rate, you just look at the data in live, give your cues to your athletes. Is not affected by the track trajectory deficit we have seen, track trajectory problem we have seen with the commercial GPS devices, and can be integrated with internal load parameters. So you can pair your heart rate monitor, maybe in the future muscle oxygenation saturation, with the nearest devices they are developing right now. What this type of device give us? Speed, of course. This is sprint session we have done with one of my athletes with the parachute. So if you can see, the first 5 reps were wearing the parachute, as you can see from the difference in speed, and the last 4 series were just without the parachute. The second output we can have is heart rate, of course, pairing our heart rate monitor. As you can see, maybe for a sprinter, looking at heart rate is not that useful. So this is why the last parameters and the most interesting, I believe, is acceleration. In this time, we got an acceleration graph that displays the acceleration throughout the single series. We can look at acceleration, we can find if our athlete is accelerating good. And for a sprinter is the max acceleration, you can see here, 5.25 meter on second square. Is a parameter you can correlate the 100-meter very well. So if you are good at the first 5-6 steps on a 100-meter race, you can say you are on the good path for a good performance. Again, acceleration can give us something we are missing as coaches, which is neuromuscular fatigue. If we look at distance or heart rate, we can measure precisely the fatigue of our athlete, the strain, the physiological requirement of the session, or the physiological adaptation. But when it comes to neuromuscular fatigue, which is something we need, because where our athletes stop skating is always because their legs hurt and never because they are out of breath. Using the accelerometer can help us in monitoring this parameter. Allows us to classify the tracks based on their layout. So there are tracks in which you are required to slow down and accelerate multiple times, maybe if a slippery track or a very short track. And then we can use this data to select the best track for a specific training session. So maybe today I've done a gym session, my legs hurt, and so I need to train on a track that allows me to do a long training session without neuromuscular fatigue. So I will select a track in which acceleration is pretty low. I don't need to accelerate after every corner. And then we can use it to test our athlete and see if they are good at accelerating, if they are missing some technical quality, or more than technical, some conditioning quality. Maybe they are just long distance athlete, so they struggle with a little bit with exit corner acceleration, and you can see everything on an objective way using these devices. What we are working on with the speed skating data is to try to develop a software dedicated to speed skating, to use this device and to monitor the training load. You can select your parameters and work on maybe today you want to work neuromuscular, and you got a neuromuscular parameter for it, and then you can track it during the year and see how your athlete is doing. The practical application of this technology are 4, maybe more, but I think the most straightforward are 4. And the load monitoring, of course, we've talked extensively later. The test and research in inline speed skating, we can start doing it with these type of devices. Safety and sport promotion, and we cover all these aspects. So from a training monitoring and programming standpoint, we have already seen that this type of device can help us increase our knowledge when it comes to training load. And knowing the training load of our athlete is mandatory when we want to be precise and we want to be effective in our programming. We can adapt the training session based on previous data. Look if our athletes are doing the required kilometers, at some intensities and stuff like that. And then we can adjust threshold of our athlete throughout the season to better match their needs. Of course, this can help us with developing new protocols, avoid maybe the overload, and reduce the risk of injury, because if we're training a sprinter and we know that if you do more than 20 seconds highly accelerations, you are more prone to injury. You just can have a look at the data from the GPS and see, okay, today we are doing 15 seconds acceleration, so we are safe. Can reduce the risk of injury for our athletes. Of course, we can use this type of devices to develop key performance indicators. So maybe we can say you are a junior athlete, you need to cover this distance in this time, okay? But you need also to accelerate good at the exit of the corner, and this acceleration must be 5 kilometers in 20 meters. And you can do some tests and see if your athlete is over or underperforming these thresholds. Can profile your athlete, and maybe you can have some radar chart with your athlete. I'm good at keeping speed high for a long time, or maybe I'm better at accelerating. We can create data set of normative data for every category. This one was pretty unexpected. This was a race from 2003, okay, last year, junior category at the Italian Championship, and it was a big crush. You've probably seen it on the web. Unfortunately, one of my athletes was in this crush. You can see him here with a white helmet, and now hit the ground very hard. And it was equipped with a GPS monitor during that race. And you can see here the start of the race, increasing the speed, then they maintain the speed high, and then here the crush, and you can find the peak deceleration for the crush. From here you can see it's around like 7 and something meter per second square, which is not that huge. You can look at these parameters maybe in live and see, okay, there is a crash, there are 10 athletes on the ground. Which one is the most important one to rescue? You look at the data, you see maybe there is a guy that crashed with a very high deceleration, so maybe the medical staff will focus on him before the other skaters. So this is a pretty interesting application of these type of devices. And lastly, of course, sport promotion. Just imagine having something like we have in Formula One, with a very good live streaming, with instant speed from every athlete, comparison between the entry speed in the corner between top skater. You can imagine doing a fly lap in the Arena Geisingen. And of course, we can do some race analysis with the data, share them after the races. These are some references I've used for the presentation, and it's pretty much everything.